Okay, here comes problem 45 on page 545. There is a sister problem here that I would look it up, but my cat is sitting on it right now. I think it's 46. This problem, I think, is a very odd problem. Let's see if you can follow this. It gives you a figure. Figure is a big triangle here. We call it OA, B, and they've dropped a couple of additional lines. That's actually doesn't look like, but that's a height, a normal to AB. They call this line C, and then they drop another height down here, D, and they say, oh, by the way, this length here is 1. And the way here's one thing that's odd about this, they use a notation that says you want to write down what the length of OA is, you do it like that. And this says that the length of O to A is 1. All right, now with that figure, they ask any number of questions. By the way, that is alpha, that is beta. All right, what's the first question? The first question is, it actually says show that the area of triangle OAC, triangle OAC is 1/2 cosine alpha sine alpha. All right, let's dive into that. Okay, area of OAC. Here's OAC right there. It's a little right triangle, and as such, this length right here, AC, is the base. This length here, OC, is the height. So the area of triangle OAC is 1/2 the base, distance A to C, times the height, the distance O to C. And now, since this right triangle has this hypotenuse 1, that's going to mean that the sine of alpha is the opposite over the adjacent, and not the opposite over the adjacent, it's the opposite over the hypotenuse, AC over 1, and the cosine is the adjacent over the hypotenuse. What's the adjacent? OC all over 1. And so look at this. OC is cosine alpha. AC is sine alpha. So sure enough, this area is just 1/2 cosine alpha sine alpha, which you were just asked to show. Okay, so that's A of ABC. Here comes B. What does B say? B says show that triangle OCB, I guess it says show that the area of triangle OCB, so we did this lower triangle, we're going to do the upper triangle probably the same way, is 1/2 OB, the distance from O to B, squared times the sine of beta times the cosine of beta. It's pretty much the same problem, only in this case OB is not 1, but we're going to do it exactly the same way. We're going to say that the area of triangle, what are we doing, OCB, is this length, the base, times this length, the height. Yeah, so let's find these things. So it's 1/2 the base, BC, times the height, OB. Okay, so let's compute these things trigonometrically. The sine of beta is the opposite side, all over the hypotenuse, OB. The cosine of beta is the adjacent side, OC, all over the hypotenuse, OB. Okay, so you can see that BC is OB sine beta, OC, how come I've got completely different? BC, OC, I wrote something wrong here. Area of triangle OCB is the base times the height, which is OC. There you go. Okay, so there's the area. Here we go. What's BC? It's OB sine beta. What's OC? It's OB cosine theta. Throw that stuff into here, and this becomes 1/2 OB squared sine beta cosine beta. So we're doing real well. What is C? C says you've found the lower triangle, you've found the upper triangle. Now add those two together and let's go find the area of triangle OAB. And they say that is 1/2 OB sine alpha plus beta. So you would be tempted to add those two guys together, but I don't really see how to add those. I'm sure you can. And this mess somehow turns into a sine of the sum of angles. But I think the other kind of question is, why was this vertical dropped? And I think you can see that the area of this whole triangle, if you use this as the base and this is the height, you're in pretty good shape, right? Because this base is 1. So let's just say the area of triangle OAB is 1/2 the base, which is OA, which is 1, times the height, which is BD. And I'm going to just write that, since OA is 1, as 1/2 BD. So let's go find BD. BD is in a right triangle right here. Hypotenuse is OB. That included angle is the sum of alpha plus beta. So the height, BD, divided by this side over here is the hypotenuse, OB, is what we call the sine of alpha plus beta. Okay? And so the length, BD, is just OB sine that. Multiply that by 1/2. That's allegedly the area. And we're going to get 1/2 OB sine alpha plus beta. Alright, so we're doing what they want. Last problem here, D, says show that OB is equal to cosine alpha. I told you this is sort of an odd problem, cosine beta. Let's see how we can do that. I feel like I've already done that to some extent. So what am I doing? I'm showing that cosine, where is cosine alpha? Cosine alpha is OC. Where is cosine beta? Oh, look at that. We've already written down, we've already done it. Go back up to the top here and see that cosine alpha is equal to OC, right? See that cosine beta is equal to OC all over OB. Okay, insert cosine alpha in for OC, and you're going to get cosine beta is equal to cosine alpha all over OB. Move that up here, move that down there, and sure enough, OB is equal to cosine alpha all over cosine. I'm not sure. This is like torture. I'm not quite, like I said at the outset, strange little problem, but sort of worthwhile to kind of exercise yourself and make use of the trigonometric functions inside a slightly complex triangle.